All right, here's page 3 of the review answer key. So I am factoring the expression 36x squared plus 25. If it were a minus, it'd be a difference of 2 squares, and we would do the square roots and write one with a plus and one with a minus. But it's not a minus. This symbol right here is a plus. So that means I have to introduce the letter I, the variable I. So I'm going to do the same idea. I'm going to take the square root of 36, which is going to give me 6. The square root of x squared, which is going to give me x, and then the square root of 25, which is going to give me 5. Because of the plus, I need to do an I with it. I write it down once with a plus sign and once with a minus sign. That's it. If I want to check, I can double distribute. So this is 36x squared minus 30xi plus 30xi minus 25i squared. So these guys cancel out. 36x squared minus 25i squared is -1. So I get 36x squared plus 25. Again, you don't have to do all of that to get the answer. The final answer is just this guy, the 6x plus 5i and 6x minus 5i. The other part was just me checking and kind of showing you why it works. Okay, these are my favorite. So I am going to rearrange it a little bit because I like to have all my stuff on the left side and my 0 on the right side. I also know that I've got to subtract 24. So I'm going to start out with that, but I'm going to switch it in the same spot. So I'm going to do x squared minus 8x plus a blank is equal to -24. So I just switched the -24 to the right-hand side and the x squared minus 8x to the left-hand side, and I left my blank. Now to fill my blank in, we take our b and we take -8, we divide it by 2, and we square it. It's always divided by 2 and it's always squared. Well, -8 divided by 2 is -4, and -4 squared is a positive 16. Now, the golden rule of algebra says if I do it on one side, I have to do it on the other. So I added 16 there. I've got to add 16 here. So my next step is completing. I've just completed the square, so now I have to figure out what the perfect square trinomial is. Well, the perfect square trinomial, because I designed it this way, is always x. This symbol is minus right here, -8, so it's going to be minus. And then I just take half of this number. So that would be 4. It's always half. Quantity squared is equal to -24 plus 16 is -8. So I am going to get -8 on the right-hand side. Then I've got to take a square root of both sides. So I'm going to take the square root here and the square root here. The square root on the left side is just x minus 4. And the square root on the right side, I'm going to rewrite as the square root of 8 and the square root of -1. Well, the square root of 8, I can actually even rewrite further and make that the square root of 4, and then the square root of 2, and then the square root of -1. So I'm going to take the square root of the things that I can take the square root of there. So the square root of 4 is plus or minus 2. So I've got x minus 4 is equal to plus or minus 2. The square root of -1 is I, and then radical 2 is trapped inside there. So I want x by itself. It's solving, so I got to get x by itself. So I'm going to add 4 to both sides. So I'm going to get x is equal to 4 plus or minus 2i radical 2. If you are stuck on this part over here, which some of my kiddos, when we did this in class the other day, this is the part that messed them up the most. What I did there is I took radical 8 and I rewrote it as radical 4 and radical 2 because 4 has a square root. The square root of 4 is plus or minus 2. And the radical 2 came down. That square root of -1 that I had there, -1, I ended up just adding that I in because the square root of -1 is I. All right, number 14. In order to determine whether these are true or false statements, we need to complete the square on our equation. So we're going to start with y equals x squared plus 6x plus 7. So I'm going to leave a blank. Y equals x squared plus 6x plus blank plus 7. In order to complete the square, I take half of this middle number and square it. So half of 6 squared is 3, or half of 6 is 3, and 3 squared is 9. If I add 9, I also have to subtract 9 because it needs to keep the balanced equation. Then I'm going to actually factor that. It should be set up so that that middle term there is 6 divided by 2. So that's going to be x plus 6 divided by 2, which is 3, quantity squared, and 7 minus 9 is a negative 2. So this is what my equation should look like. This would give me a vertex at negative 3, negative 2. Remember, when we're with our x, we go opposite. So that means that A would be false, B would be true because it matches. It has a minimum at negative 3, negative 2. That would be true because that's the vertex. And the domain for any quadratic is all real numbers, so this would also be true. All right, this one we're going to use the quadratic formula. So our A is 1, our B is negative 3, and our C is 8. So quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I need to just plug those numbers in. So I get the opposite of b, which is a positive 3, plus or minus the square root of negative 3 squared minus 4 times a, which is 1, and c, which is 8, all divided by 2 times 1. Okay, now this whole thing that's underneath the radical right here, this I'm going to put into my Desmos app, and it's going to tell me what that is because I don't want to do that in my head and make a silly mistake. So let's check out what Desmos tells us. Okay, so there's what I get when I plug it into Desmos, which is a negative 23. So that's going to give me 3 plus or minus the square root of negative 23 all over 2. Well, the square root of negative 23 is really the square root of negative, or 23, and the square root of negative 1. And remember, negative 1 is I. So this becomes 3 plus or minus I, radical 23, all divided by 2. All right, so we're going to do it again. Quadratic formula, A is 1, B is negative 6, and C is 4. So it's x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So when I plug that in, it's going to look like the opposite of b, which is positive 6, plus or minus the square root of negative 6 squared minus 4 times a, which is 1, times c, which is 4, all over 2 times a, and a is 1. So again, I'm just going to plug in right here this guy into my Desmos so I can get what the radical representation is. So let's see what that is. All right, so I plug that in. So that gives me 6 plus or minus radical 20 all over 2. Well, radical 20, remember, we can take radical 20. We can break that down into perfect squares. 4 is a perfect square that goes into 20. The square root of 4 is 2, so that becomes a 2 radical 5. So this ends up being 6 plus or minus 2 radical 5 all over 2. I can chop each of these in half, which gives me a total of 3 plus or minus radical 5. Okay, so this problem is 2 parts. First, I need to know whether the ball reaches a height of 16 and what equation would I use. Well, if the ball does reach a height of 16, then when I look at the graph, that y value should be higher than 16. To me, that's the easiest way to look at this problem. So I'm looking for the vertex, and since the vertex in this one does go higher than 16, then I can say yes, it does reach a height of 16. It actually goes farther than 16. So I think the graph tells us a lot here. The blue graph is just the graph of that actual parabola. And we can see that the height is clearly above 16 because it actually goes up to 20 something, 22, I think. I can also solve the equation using my graph and show that negative 5x squared plus 20x plus 4 equals 16 and show that there are solutions where that actually happens. That happens at 0.7 seconds and that happens at 3.265 seconds. So as it goes up and as it goes down, my ball will actually reach the height of 16 both times. So this would be my equation that I would want to solve, so I could use that to be able to tell if it does reach that height, but the graph to me tells me even more than the equation does. This problem is a discriminant problem. So discriminant, remember, is just the stuff that's underneath the radical, so b squared minus 4ac. And this wants me to know when will I have one real solution. So I know that I have one real solution when my discriminant is exactly equal to 0. I have two reals when I'm greater than 0, and I have no reals or two imaginary when I'm less than 0. So here I want to figure out when does b squared minus 4ac equal 0. So again, here's my a, 4. B I don't know, so I'm going to leave it as b. And then c is 25. So I'm just going to go ahead and plug those in. So here's my b squared. And, let's try that again. B squared, and then my a and my c. So my b squared here, I don't know, so I'm going to leave it as b squared minus 4. My a is 4, and my c is 25. And I want to know, when does that equal 0? Well, I can solve for a lot of this. The first part there is when I do b squared minus 4. So I'm just going to do this part right here in my graphing calculator. So let's see what that equals. Okay, so b squared, so minus 4 times 25 is 400. So that gives me that b squared minus 400 is equal to 0. So I'd add 400 to both sides. And b squared would equal 400. And then I would take the square root. And so b would equal positive or negative 20. So this means that as long as b is either exactly 20 or exactly negative 20, I will get one real solution. All right, this one I'm going to put into my graphing calculator. I'm going to put in each one of those in a separate line. Check out the graph. However many times it intersects is how many solutions I have. So let's see what that looks like. All right, so from the graph, I can see that they don't intersect at all. There is no intersection, so this has no real solutions. If it intersected, however many times it intersected would tell me how many solutions it had. If I just touched the graph, it would be 1. If I actually intersected twice, it would be 2 real solutions. All right, the final problem. All I'm doing here is graphing both of these. So I put the left-hand side in one part and the right-hand side in the other, and then I'm checking where they intersect. I'm only looking at the x values. So these two graphs intersect at negative 1.608 and 3.108. So those would be my two solutions to this equation. Good luck on the common assessment, guys.